Hello students, today I am here with Chemistry of Class 10, Chapter 1, Chemical Reactions and Equations. Chemical Reactions and Equations. What is chemical reaction? I will explain what is chemical reaction with some examples. Example number 1. Take a magnesium ribbon. All of you might have seen magnesium ribbon in your chemistry lab. First of all, rub it with a sandpaper. Clean it with a sandpaper and burn it. Why are we rubbing a magnesium ribbon before burning it? Because magnesium, when exposed to air, it will react with atmospheric oxygen and can react with atmospheric oxygen to form magnesium oxide, and there will be a layer of magnesium oxide formed over it. So by rubbing with sandpaper, we are removing that magnesium oxide layer, then only it catch fire easily and will burn. So rub it nicely and show it in a burner, and you can see that magnesium ribbon will burn with a dazzling white light. Magnesium burns vigorously with a dazzling white light, and you will get some white powder. That white powder is of magnesium oxide. So the first example, when magnesium is burnt in air. Burnt in air means in chemistry plus oxygen or plus air. But we know that oxygen of the air is used for burning, gives magnesium oxide. The white powder that you got after burning is magnesium oxide. Another example, take some zinc granules. Zinc granules, small pieces are called granules, in a test tube or in a conical flask, and add some dilute hydrochloric acid or dilute sulfuric acid. Watch the test tube or the conical flask. What do you observe? You can see around that zinc granules, you can see the formation of some bubbles, and that bubbles will slowly start coming up. And if you touch the test tube or the conical flask, you can see that the test tube and the conical flask is hot. So there are two observations in this example. When zinc granule is treated with dilute hydrochloric acid or dilute sulfuric acid or with any dilute acid, two things are observed. Number one, evolution of a gas. That bubbles indicate some gas is formed, and you can see that bubbles will come up. And the test tube is getting heat. What does it mean? Test tube got heated because heat is also evolved in this reaction. So zinc plus dilute hydrochloric acid or sulfuric acid or any acid gives some gas and heat. Maybe something else that we will see later. Another example, take lead nitrate solution in one test tube. Lead nitrate solution, and add potassium iodide into it. Lead nitrate solution and potassium iodide are mixed together, and see what is observed. You can see suddenly the color of the test tube will turn into yellow. Lead nitrate and potassium iodide both are colorless solution, but when they are mixed together, you can see an yellowish appearance in the test tube. The color of the test tube is suddenly changed into yellow. So what is observed there? Change in color. So in all the three examples, we have noticed in the first one, what happened? Change in state. This magnesium ribbon, when heated in open air, we got some white color ash. In the second one, when zinc granule is treated with any dilute acid, we got a gas and heat. So liberation of a gas and liberation of heat. Here, change in state. And in the last one, lead nitrate and potassium iodide, what happened? Change in color. So this is the definition of a chemical reaction. Chemical reaction is a change or it's a chemical action which involves either change in state or change in color or evolution of a gas or change in temperature. So a chemical reaction must involve in any of these four, not all the four together, but it will involve in any one of these four. Then such a change is called a chemical reaction. This is the first part of the chapter. What is a chemical reaction? When two substances combine together, a new substance will be formed. When that new substance is formed, in that entire process, you can see any one of these four changes. So we have explained three examples, and in all the three examples, you might have seen any one of these four things is occurred. Now I am coming to the next part of the chapter. What is a chemical equation? What is a chemical equation? A chemical equation is a symbolic representation of a chemical reaction. I repeat, a chemical equation is a symbolic representation of a chemical reaction with the help of symbols and formulae. All of you are well aware of symbols and formulae. I just studied in class 7th and 8th. Using symbols and formulae of the reactants and the products, we will represent the chemical reaction symbolically. This symbolic representation of a chemical reaction is called a chemical equation. If I go back to the previous example, magnesium when burned in air, we got magnesium oxide. Now, how can we make the chemical equation of that same? Magnesium, its symbol is Mg, plus burned in air means combining with oxygen. We know that symbol or formula of oxygen is O2, forms arrow mark. So magnesium and oxygen are the reactants here, and what is the product form? Magnesium oxide, and the formula of magnesium oxide is MgO. This is called a chemical equation. The symbolic representation of a chemical reaction is called chemical equation. Now we will come to the later part where this chemical equation is to be balanced. Balancing the chemical equation, I will explain it later. So it is not a balanced chemical equation now. Since it is a separate topic, I am coming to balancing the chemical equation in the later part. Second example, what was that? Zinc, when treated with dilute hydrochloric acid or dilute sulfuric acid, any acid you can say, Okay, let's take H2SO4, sulfuric acid, gives ZnSO4, zinc sulfate plus hydrogen. The gas which was liberating from the test tube was hydrogen. And the zinc granule, after the reaction, that zinc granule will become zinc sulfate. So zinc symbol is Zn, sulfuric acid formula is H2SO4. The product formed are zinc sulfate, formula ZnSO4, and the gas released is H2. Third one was lead nitrate plus potassium iodide. Lead nitrate plus potassium iodide. Potassium iodide is Ki. Lead nitrate is PbNO3 twice, gives potassium nitrate KNO3 plus lead iodide PbI2. This lead iodide is yellow in color. So here what happened? Change in color. So the third example is symbolically represented. So these are called chemical equations. Symbolic representation of a chemical reaction using symbols and formulae. I think it is clear to all of you. In this way, we can write all the chemical reactions in this form using symbols and formulae. This is called a chemical reaction. Our next part is how to balance a chemical reaction. I told you these are not balanced chemical reaction. Now I am going to explain how to balance a chemical reaction. How to balance a chemical equation. So balancing the chemical equation is the next topic. Okay. I am taking the first example. Magnesium ribbon is burned in air to form magnesium oxide. To balance a chemical equation means to make the number of atoms of each element of the reactant equal to number of atoms of each elements of the product. I repeat, in a balanced chemical equation, number of atoms of each element that take part in the chemical reaction, which is called the reactants. Here Mg and O2 are called reactants, reactants, and MgO is the product. So balancing a chemical equation means the number of atoms of each element present in the reactant must be equal to number of atoms of each element present in the product. Now let's see how can we do it. So first of all we will write name the elements present. Then we will write number of atoms of that particular element in reactants. Then let us see what is the number of atoms of that particular element in product. So I have made a table like this. I will be writing each element that take part in the chemical reaction. We know that the elements that takes part in the chemical reaction will be the same that you will see in the product also. No new element is formed in a chemical reaction. So you just see the LHS. Left hand side of the arrow mark, the elements will be same on both the sides, but their number of atoms may change. We have to make the number of atoms of all the elements in the reactant is exactly equal on both the sides. This is called balancing a chemical equation. So, I am going to write the elements that take part in this reaction. First element is Mg. Second element is O. Magnesium and oxygen are the two reactants. Same magnesium and oxygen can be seen on RHS also. What is the number of atoms in reactant? Number of atoms of magnesium in reactant is 1. What is the number of atoms of magnesium in the product? Here also it is 1. Now come to oxygen. What is the number of oxygen atoms in the reactant? It is 2. What is the number of oxygen atoms in the product? It is 1. So, this is okay. Mg 1 1, it is balanced. But oxygen is 2 in the reactant, but there is only 1 in the product. So, this is not balanced. So, now our aim is to make the number of oxygen atoms equal on both the sides. But, while making number of oxygen atoms equal on both sides, the number of magnesium atoms may also change, because while balancing a chemical equation, we cannot touch the formula of a compound. Formula of magnesium oxide is MgO. This formula MgO cannot be touched. Like chemical formula of water is H2O. It will always remain as H2O. For balancing, you cannot make it as H2O2 or H1O2. No. H2O is always fixed. Similarly, MgO is fixed. So remember, chemical formula of a compound is always fixed. You cannot change their atoms. But what can be changed? We can change the number of molecules of it. Where will you write number of molecules? Number of molecules will be written on the left side of the formula. You can make MgO as 2MgO, 3MgO, 4MgO. Any number can be written here to the left of it. That number represents number of molecules. So for balancing a chemical equation, you can increase the number of molecules, but don't touch this formula at all. Similarly, you can make it as 2O2, 3O2, 4O2, 5O2, any O2, but O2 will remain as O2 only. You can make it as 2Mg, 3Mg, 4Mg, 5Mg, but you can never make it as Mg2, Mg3, Mg4, no, never. O2 will remain as O2. You can never make it as O1 or O3 or O4. Did you understand the difference? This is called symbol and formula. Symbols and formulas are to be maintained as it is. But you can only increase the number of its molecules. Means, any numerical number can be given to the left side of these symbols. That number represents number of molecules. So, number of molecules can be changed for balancing a chemical equation. Now, let's see. Mg, right on both sides, equal. O2 and O1, this is the problem. Here it is 2, here it is 1. So, how can we make it also 2? As I told you, number can be given only on its left side. Okay, I am giving here 2. So, now how will you count the number of atoms of Mg and O? This 2 is applicable for both Mg and O. Now what is the number of Mg atoms? 2. What is the number of O atoms? Also 2. Here it is O2. Here also now it is O2. Number of oxygen atoms are balanced. But a new problem arises. What is that? Here it was 1 Mg. Now it is 2 Mg. So now we have to make Mg atoms also equal. How can we make Mg atoms equal? By putting 2 here also. Now it is balanced. 2 Mg, 2 Mg. O2, O2. Now it is balanced. This is the way of balancing a chemical equation. Always do it with the help of a pencil because it's a type of trial and error method. Hit and error method. So using a pencil you may give these numbers. May be possible later on we have to change this number. For making one atoms equal on both sides we may give 2. Later on we may see that while giving 2 if the other atoms may get disturbed. So sometimes we have to rub it and change it again. So always use a pencil because it's a hit and error method or trial and error method. So finally when we get both the sides number of atoms of each element equal, it is called a balanced chemical equation. I will explain with one more example. So now it is balanced. Number of atoms on both the sides are equal. Mg 2, 2. O 2 and 2. Now both the side number of atoms are equal. So it is balanced. Now take another example. Some more examples are given in your book. So, I am not going with the examples given in your NCERT book because you can see it and understand. Zn plus H2SO4 gives ZnSO4 plus H2. The method is explained in the book, so you can go through it. Another one is given. Fe plus H2O gives Fe3O4 plus H2. This is also explained in the book. So, you can see and understand the balancing of these chemical equations. It is given in explained form. Now one more part, writing symbols of physical state. In a balanced chemical equation, we will also use some symbols for making it more informative. The symbols that are used for making a balanced chemical equation more informative are temperature changes, physical state and temperature. Now, solid, liquid and gas are also mentioned along with the symbols. That is one way of making it more informative. And evolution of gas is mentioned. Presence of temperature is mentioned. Presence of atmospheric pressure is mentioned. So these are the extra symbols that we use in a chemical equation for making it more informative. For example, the gaseous, liquid, aqueous and solid states of reactants and products are represented by the symbol G. Small g is used for gas, L for liquid, AQ is written for aqueous solution. What do you mean by aqueous solution? Solution in water is called aqueous solution. If that substance is a solution made in water, then we will write AQ to the right side of that. And S for solid. So this is gas, this is liquid, AQ represent aqueous solution and S for solid. Okay. Now, extra informations will be written about the arrow mark. For example, if there is atmospheric pressure involved in that chemical reaction, that will also be mentioned. For example, CO, carbon monoxide, plus 2H2, hydrogen gas, gives CH3OH. Methanol. So carbon monoxide is a gas. So we will write here CO in bracket G. H2 hydrogen is also a gas. Now, this reaction takes place at 340 atmospheric pressure. So we will write here 340 atmospheric pressure, and the product formed is CH3OH. It is called methanol or methyl alcohol. It is a liquid. So we made it more informative by showing the physical state. It's a gas, it's a liquid, and 340 atmospheric pressure is needed for this chemical reaction to take place. So that is mentioned above the arrow mark. Temperature. If that reaction occurs at a particular temperature, that particular temperature will also be mentioned above or below the arrow mark. So temperature and pressure will be represented or shown above or below the arrow mark. Physical state of the reactant and the product will be shown in small brackets as suffix. So in this way, chemical reactions can be made more informative. Now, I am coming up with more examples of balancing a chemical equation in the next video. Till then, please go through these topics taught today, and we will come with more and more examples of how to balance a chemical equation. Until then, thank you. Bye bye.